All right, let's go ahead and get started. Thank you, everybody, for coming today. We're here on the third installment of our Growing Inside the Box webinar series. Today, we're going to be talking about macronutrient management, how to really identify those deficiencies in hydroponic systems and what to do about it when it occurs. So like I said a few minutes ago, the chat and the Q&A session are both open. So feel free to drop questions in either of those at any time, and we'll get to those during the Q&A section at the end of the presentation. So today we're going to be covering two main sections. The first section is macronutrient deficiencies. We're going to talk about what macronutrients are, the differences between mobile and immobile macronutrients, and the visual symptoms of nutrient deficiencies. What to look for, how to identify those deficiencies when they pop up. And in the second section, we'll be talking about where macronutrients come from, what the significant sources of macronutrients are, nutrient antagonisms, and nutrient toxicity we'll cover very briefly as well. So diving right into section 1, macronutrient deficiencies. What are macronutrients? So macronutrients are the elements that are required by plants in the greatest quantities. Your primary macronutrients that you're usually going to be looking for are nitrogen, phosphorus, and potassium. And then we also have secondary macronutrients. They're still macronutrients, but they're not needed at quite the same rate as the nitrogen, phosphorus, and potassium. And those are going to be calcium, magnesium, and sulfur. Let's talk about nitrogen for a second. Nitrogen is needed by plants in the greatest quantity. It is the macronutrient of all macronutrients. It's required for pretty much everything that a plant is going to do, including building amino acids, proteins, nucleic acids, and it's crucial in chlorophyll production, which is why when you have a nitrogen deficiency, generally you'll see yellowing, so the plant isn't producing as much chlorophyll. It's going to start to look a little bit less green. Nitrogen sources are most available at a pH between 6 and 8. And there are two main forms of nitrogen that can be supplied to plants that the plants can take up directly, and that's nitrate nitrogen and ammoniacal nitrogen. So nitrate is abbreviated as NO3, and ammonium is abbreviated as NH4. You can also supply nitrogen to plants as urea. A lot of fertilizer sources will list urea as a source of nitrogen, but urea does need to be converted to ammoniacal nitrogen before the plant is able to take it up. Urea can be absorbed directly through plant leaves, but that's not very common in CEA agriculture, and so I wouldn't really consider that to be a major source of nitrogen in hydroponic and CEA systems, but it is an option when you're dealing with, a really significant deficiency that you need to correct very quickly. Phosphorus is our next macronutrient. It's also very important and needed by the plant to produce ATP, nucleic acids, phospholipids, lots of different enzymes. And it's required in ATP and ADP, which create and release energy in the plant. So it's really important during that photosynthetic process. And phosphorus is a little bit different. It's most soluble between 6.5 and 7. And then it's also very soluble at pHs above 8.5. Naturally, we wouldn't really recommend this in a CEA or hydroponic system, just because that is the range at which most other nutrients are unavailable. But, if you do have a pretty dramatic pH swing, at least you'll still have phosphorus available. At very low pHs, phosphorus can bind with iron or aluminum, and that renders the phosphorus unavailable. And if it binds with iron, that also renders the iron unavailable, which is why it's really important to keep the pH, in that optimum range at all times. Phosphorus is mainly absorbed by plants through passive uptake, so the plant doesn't need to expend any energy to pull that phosphorus out of a nutrient solution. And this isn't really an issue in CEA and hydroponics, but phosphorus is immobile in soils. So if you do have other plants that you're growing, outdoors and maybe more traditional agriculture, Phosphorus can be really tricky because if it binds with those soil particles and it's out of reach of the plants aren't going to be able to take it up, even if it is technically in the soil and available. Next is potassium, which is required for protein synthesis. Potassium is really important during fruit and flower development. So if you're growing vegetable or fruiting crops like tomatoes, peppers, cucumbers, you're really going to want to increase that potassium as those fruit are maturing. Um, like most other nutrients, potassium is most soluble at a pH around 6 and above. And it's also, like phosphorus, taken up passively, so the plant does not need to expend energy in order to take up potassium. Next, we have calcium, which is required for the maintenance of membrane structures and membrane integrity. That's why whenever you have a calcium deficiency, you'll likely see tissue necrosis very quickly. Those cell structures are just breaking down. Plants will also wilt and show, they'll look kind of soft, a little floppy, sometimes almost soggy. And that's just because those cell membranes really are breaking down and the plant doesn't have the structure to be able to hold itself up. Calcium is absorbed as a +2 ion, so it's positively charged, and it is also taken up passively. However, the difference with calcium is that the uptake is restricted to those actively growing root tips. So if your plant has significant roots, the plant can only take up calcium through the very end of those roots, which is why whenever you have root damage, if you had a fungal or a pathogen that really damaged the roots, or an improper pH even that was significantly too low that caused root damage, even if calcium is available in the nutrient solution, your plant may struggle to take it up because it can only absorb it through those actively growing root tips. Calcium is also taken up passively and it moves through the plant with water, which is why transpiration is incredibly important because it helps to move the calcium through those root tissues and the leafy tissues. However, once it's deposited in wherever it was headed to, it's going to be immobile. It's not going to be able to move through those tissues again, even if there is plenty of water. Next is magnesium. Magnesium is also crucial for the development of chlorophyll. That's why whenever you see a magnesium deficiency, it will often be interveinal chlorosis. That chlorophyll just isn't being produced in those areas. You'll start to see yellowing. It's also needed for several other plant functions like protein synthesis and any reactions involving phosphate transfers. All of these nutrients really just work together to, help the plant continue to create energy, create chlorophyll. And like most other macronutrients, it's taken up passively. The plant does not need to expend energy in order to take up magnesium. And finally, we have sulfur. Sulfur is a macronutrient that can be supplied in really significant quantities and doesn't compete with many other nutrients for uptake. It's required to construct amino acids and proteins. It's also a component in the lipids that form parts of chloroplast membranes. So it's also pretty important in chlorophyll production as well. And sulfur is a little bit interesting in how much needs to be supplied to plants. For the majority of plants, a nitrogen to sulfur rate to supply that would be adequate is 15:1. So that would be significantly less sulfur than nitrogen. However, if you're growing brassicas, anything in the brassica family, also called crucifers, they need significantly more sulfur, which is what kind of gives them their trademark bitter flavor, and you can kind of smell them sometimes. I know everybody here has experienced someone opening up a pack of broccoli for a snack and maybe has to leave the room. That's because of the sulfur content in those plants, and it needs to be supplied to them at about 3:1, which is significantly more than most other crops. So now we'll talk about the difference between mobile and immobile nutrients. Mobile nutrients are able to move through plant tissues. So even though they have been deposited in a particular area, if the plant is starting to, experience a deficiency of a mobile nutrient, it will be able to relocate those nutrients from older tissues to the newer, more actively growing tissues, which is why deficiency symptoms will appear in those older tissues first as the plant remetabolizes and moves those nutrients from the old tissues to the new tissues. And then immobile tissues are fixed, or immobile nutrients are fixed in plant tissues. Once they've been deposited, they cannot be remetabolized and moved to actively growing tissues. So if you're experiencing a deficiency of an immobile nutrient, you'll notice that in those new, more actively growing areas first. So just to break it down, here's the list of which macronutrients are mobile and which are immobile. Nitrogen, phosphorus, potassium, and magnesium can all be relocated through the plant. So if you have a nitrogen deficiency, you'll see it as slower growth, but the significant chlorosis that you would see from a really dramatic nitrogen deficiency will start to show in those older tissues first. Calcium and sulfur are considered immobile, so you'll see the deficiency symptoms of both of those in the newer tissues first. Now, sulfur is slowly mobile. It can move, so a deficiency may present as a little more evenly spread through newer and older tissues. But that being said, it's so slowly mobile that it is generally considered to be immobile. So let's look at what the deficiency symptoms of each macronutrient actually present as and how to identify them. So nitrogen deficiency is going to be one of the more common ones. As I said, nitrogen is required by plants in the greatest quantities. So if you start to have lower nitrogen, your plant is going to exhibit symptoms of deficiency much faster than would be typical with other nutrients. Nitrogen deficiency presents as chlorosis, starting in older tissues, because remember it is mobile, so the plant will be able to move it to those newer, more actively growing areas. And it kind of exhibits as general chlorosis with no distinct pattern. But the biggest symptom that you're going to see of nitrogen deficiency is just reduced growth in general. So the picture that we have here is an example of a healthy head of lettuce compared to a severely nitrogen deficient head of lettuce. You can see with the healthy lettuce, the leaves are large, they're dark green, they're evenly spaced. Whereas with the nitrogen deficient lettuce, those older leaves are smaller, they're turning yellow, they're not full enough to overlap each other. Even though the center of the head does look relatively healthy, it's kind of dark green, it looks like it's doing okay. The plant in general is stunted and, will not have a very high yield. Phosphorus deficiency is a little interesting. This isn't one that we run into very frequently. But like nitrogen deficiency, the growth will be restricted. You'll start to see lower yields. And then in terms of chlorosis patterns, you'll see chlorosis starting around the edges of the leaves and creeping in towards the center. Depending on the type of plant, you'll also notice really distinctive purple coloration on the undersides of the leaves. So if you flip the leaf over and the bottom of the leaf looks a little more reddish or more purple than the top of the leaf, that would be a key indicator of phosphorus deficiency. You'll also notice lower leaves kind of starting to dry out. The roots aren't going to be growing and searching out those nutrients as much as they should be. And for fruiting crops, you're going to notice significantly delayed fruit set. This frequently happens when the root zone is cool. It's also very damp. In true hydroponic systems where you're running with pretty much just basically water, this is going to be really difficult to control. Um, However, it doesn't matter quite as much because the phosphorus does move with the water and will be within reach of the roots. Now, if you're growing in some type of a substrate and the substrate is constantly remaining damp, then those plants may struggle to take up the phosphorus that's being supplied. Um, like I said, whenever we were discussing phosphorus in a true soil system, phosphorus can bind with the soil and end up out of reach of the plants. This isn't usually a concern in hydroponic systems, as that solution is constantly bathing the roots with phosphorus-rich nutrient solution, but it's not impossible that you might end up with a phosphorus deficiency if nutrients become imbalanced. Potassium does have a very distinct nutrient deficiency pattern, very kind of scattershot, mottled spotting on leaves, and it very quickly evolves into necrosis rather than just chlorosis. So chlorosis is going to be the yellowing of sections of the leaf, and necrosis is where those sections begin to die. As you can see in this picture, those necrotic spots are very dry, they're brown, kind of crispy. And you'll also notice with potassium deficiency that the leaves will start to curl and cup. So that paired with the necrotic spotting is pretty much textbook. This is a potassium deficiency. This is what to look for. With plants that don't grow in a rosette pattern, like, head lettuce or something like that, if you're growing tomatoes, anything with a stem or a stalk, you'll notice that those stems are very slender. They're very easy to break, and they won't really hold, fruit very well. You'll also notice if you have a chance to look at the roots are probably underdeveloped and they're really not growing and searching out nutrients either. Next, we have calcium. Calcium is one of the biggest deficiency issues, especially with head lettuce and other kind of rosette-shaped plants. The biggest issue with calcium is that it is immobile. So, like I said, it moves with water through the plant tissues, but if the water is not being drawn through those plant tissues, it's not able to reach all of the parts of the plant where it may be needed. So, specifically in head lettuce, those really tightly growing plants, if there's not enough air movement, if the air is too humid and the plants aren't transpiring through all of those tissues, the calcium is not going to be drawn all the way through those new leaves, especially in the center of those very tight heads. So you'll start to see tip burn is what we call this in lettuce. It's just kind of drying and necrosis of the edges of those very new leaves. Um, and as it progresses, you'll see sometimes even deep down in the head of that lettuce that the all of the new leaves will kind of die, and you'll end up with a just kind of a necrotic hole in the middle of your head lettuce. Calcium deficiency can be caused by several factors. It's not always that there's just low calcium in your hydroponic nutrient solution. Oftentimes, potassium, calcium, and magnesium all compete for uptake. They're all similarly charged. So, an imbalance of that ratio can also cause calcium deficiency. And, like I said, environmental conditions like high humidity or very low air movement that's restricting the plant's ability to draw water all the way through those tightly bunched tissues can also cause calcium deficiency. Next, we have magnesium. Magnesium is another one that has a pretty distinct chlorosis pattern, making it easy to identify. For magnesium deficiency, you're going to see interveinal chlorosis, which means that all of the leaf tissue in between the veins is going to start to turn yellow first. And you'll end up with these really dark green veins, and the rest of the leaf will start to be yellow. Like I said, with calcium, it doesn't always mean that you're low in magnesium in your nutrient solution. It could be that you're supplying too much potassium or too much calcium, and that's really restricting the plant's ability to be able to take up that magnesium that is being supplied. And finally, we have sulfur. Sulfur, like I said, is a little bit of an interesting one. Deficiency in sulfur does not happen very frequently with CEA crops, but it is possible. Because sulfur is slowly mobile, the deficiency symptoms will appear first in young leaves. However, the symptoms are very uniform chlorosis and stunted growth, which makes it very easy to confuse with nitrogen deficiency. And because the newer leaves tend to turn very bright, light green, almost yellow, it's also very easily mistaken for iron deficiency, which we'll cover when we do micronutrients. On some types of plants, depending on the severity of the deficiency, it can also cause almost reddish vein color in the leaf undersides, so almost similar to phosphorus deficiency, but that discoloration would be seen more in the veins rather than evenly spread over the underside of the leaf. So now that we've gone over deficiencies and what they look like, let's talk about how to manage deficiencies when they occur. You're going to have three main sources of macronutrients that are really going to, you need to keep in mind all three of them to understand what is being input into your nutrient solution. So, the most significant source of macronutrients is going to be from your fertilizer plan. So, whatever type of fertilizer you're using, always keep in mind the guaranteed analysis of all of your fertilizer inputs. For example, this is the guaranteed analysis for our 6626 low phosphorus part A. So as I'm sure all of you are aware, with this formula, we're supplying 6% nitrogen, 6% phosphorus, and 26% potassium. So you definitely want to keep in mind that, those rates aren't exactly what we're targeting, which is why we always pair it with our 1500 calcium nitrate. And so you would want to keep in mind both of those whenever you're trying to calculate how much nitrogen is being supplied, since nitrogen is going to come from both of those sources. The next big input that could be a source of macronutrients is just going to be your water. Lots of water sources, especially if they're not pure water sources like deionized or RO water, are going to carry with them some level of nutrients. So, this is an example of a well water source, and you can see that it contributes a significant amount of calcium, magnesium, and sulfur. Not so much nitrogen, phosphorus, or potassium, but whenever you're deciding which fertilizers you need to use, always keep in mind what is available from the source water and try to balance that with what is being supplied by the fertilizer. And I did also want to point out that there is 22 parts per million and 65 parts per million of sodium and chloride. So we always want to keep in mind how many extra minerals are being supplied as well, especially from the source water. And keep in mind that that's going to contribute to our EC as well. So keeping in mind how much that's going to contribute to the EC and accounting for that whenever we're setting our EC set points to make sure that the plants are still getting adequate nutrients, even as that EC changes over time. And finally, your pH up or down solutions. We all know that our hydroponic nutrient solutions, the pH needs to be continuously monitored and kept in that range where nutrients are always going to be soluble and available. But most pH up and pH down solutions are going to contribute some type of macronutrient. So, for example, our pH up is a potassium bicarbonate and it's 35% potassium. So if you look on the back of the label, we've even broken it down in a table that shows you how many parts per million of potassium you would be supplying at whatever rate that you're needing to add the potassium bicarbonate to your solution in order to manage your pH. So this is going to help you really keep track of how much potassium is being added over time. So you know how better to balance the other inputs of your fertilizer and water to keep those nutrient ratios in check. And then we always want to keep in mind the solution pH and alkalinity. We've talked about this several times, but it's always good refresher to go over that all of the nutrients your plants are going to need, macro and micronutrients, are going to be most soluble at a pH range between 5.5 and 6.5. So whenever we're managing our solutions and trying to keep that pH in check with either our pH up or down, this is the range that we're always shooting for. And in that same vein, it's always important to keep in mind your solution alkalinity, especially if you're not starting with a pure water source, like I said, like DI or RO water. If you have a well water source that's very hard, your alkalinity may be very high. And the higher your alkalinity, the more it's going to take to change your pH. So if you need to bring your pH up with our potassium bicarbonate and already have a lot of alkalinity in your water, you're going to be adding significantly more potassium than you probably planned on just to keep the pH manageable. And then you have to remember that those nutrient ratios are going to change over time in recirculating systems. So this is an example of a freshly mixed nutrient solution. We're targeting an EC of 2, which is fantastic for most CEA crops. And you'll see that we have mixed at about 200 parts per million nitrogen. Everything else is pretty in check. Our potassium to calcium to magnesium ratio is relatively close to where we want it to be. But this same solution, after just recirculating for 3 weeks and maintaining that EC of 2, has a significantly different ratio. So if you're monitoring based on EC, you know that just because your EC is right where you want it to be, you may not be supplying the nutrients that your plants need. You'll see that the nitrogen has dropped to functionally nothing. Our phosphorus has climbed from 144 to 329 parts per million. And our potassium to calcium to magnesium range is, been thrown off a little bit. And then I did want to touch again on the nutrient ratios, especially of those positively charged ions, the potassium, calcium, and magnesium. We really try to keep those three at a ratio of 4 to 2 to 1. This is going to supply those nutrients in the same rates that the plant is going to need them and use them. And since the plant can't really tell the difference between those positively charged ions, it can't pick and choose. We need to make sure that we manage the ratio of these nutrients so that the plant is taking up and getting what it needs. So I've kind of used this example of how much potassium and calcium and magnesium are supplied by our formulas that I've recommended to several of you. And you'll see that the rates are pretty close to that 4 to 2 to 1, but keep in mind that the specific ratios are going to change based on your water source. So always get your water tested before deciding which nutrient formulations you're going to want to use, because the amount of calcium and magnesium supplied in the water usually balances this out and puts it closer to a 4 to 2 to 1. And then, like I said, with that well water example, we do always want to keep in mind how many extra minerals are naturally occurring in the water, specifically sodium and chloride. So this is an example of a recirculating solution that was maintaining their EC at about 1.5. Their potassium, calcium, and magnesium, were doing okay at about 10 days. And then all of those started to, change significantly over the course of the next couple weeks. But the sodium climbed over time, and that's what was keeping the EC at that pretty steady and consistent 1.5. So this particular grower was seeing symptoms of potassium deficiency. We couldn't really figure out what the issue was. They knew that they were supplying plenty of potassium, but as soon as that potassium hit the system, it was taken up by the plants right away. And there wasn't very much potassium being added in the first place because the EC was staying at that consistent 1.5. The system, didn't recognize that the EC was being driven up by sodium rather than by plant essential nutrients. And now we'll just kind of briefly touch on nutrient toxicity. This isn't very common in CEA and hydroponic systems, but nutrient toxicity is an overaccumulation of nutrients, which leads to excessive uptake. Toxicity symptoms can very closely resemble deficiency symptoms. So it's always important to keep in mind what is in your solution, get your tissue tested, before trying to treat a deficiency or toxicity to positively identify what the problem is. So as I said, nutrient toxicity is rare in CEA crops. Um, Particularly because CEA crops are more short-term than, say, like a traditional agricultural crop, and well-managed solutions rarely accumulate nutrients to the level that they would cause a toxicity. And in general, even if you suspect that you have a toxicity, most toxicity symptoms are actually deficiency symptoms of other nutrients. So using, again, potassium, calcium, and magnesium as an example, an excess of potassium may not cause a potassium toxicity, but it could cause a calcium or magnesium deficiency as the plant isn't able to take up calcium and magnesium due to the excess of potassium. And then that's just really a good reminder about our lab testing services. Routine lab testing is the best way to avoid these nutritional issues, keeping an eye on what specifically is in your solution as it recirculates, being able to track those nutrients over time and see how they change to get a better feel on what kind of updates need to be made to your fertilizer plan and your recirculating solution. And then before you start to treat any particular deficiency or maybe even toxicity, you should always, always, always get your solution tested and sometimes even get your plant tissue tested so that we can positively identify the cause of the issue instead of, just throwing things at the system and hoping that it fixes whatever the problem is. So our lab does offer tissue media and solution testing. So if you do think that you're having an issue, absolutely send samples to us. We can get it figured out and try and get it fixed as quickly as possible. So our big three key takeaways today are: one, macronutrients need to be supplied in the greatest quantities. Never forget that macronutrients are your main source of nutrients. The plants need them for all their metabolic functions. And it may take more than one nutrient input to supply the proper rates of nutrients. So if you're using a two-part system like our 6,6, and 1500, you can't depend on just one or the other to be the main source of, say, nitrogen. You're going to need both of them. And then macronutrient deficiencies can result from several factors. Of course, the first thing that comes to mind is that, well, this nutrient is low and that's why there's a deficiency. But overall, that may not be the case. It may be an imbalance of other nutrients. It could be improper solution pH. It's always important to check all of the boxes before deciding how to treat a particular deficiency. And then finally, lab testing is always going to be the most accurate tool for diagnosing and avoiding these nutritional disorders. Obviously, you need to monitor your EC and pH every day, keep that in check and in range. But whenever you're experiencing an issue, a comprehensive nutrient analysis is going to be the best way to positively identify the issue and maintain consistent crop health over time. And that's going to wrap it up for today. I have a link to our lab testing services here and my contact information. And then if anybody has any questions, feel free to put them in the chat or the Q&A. We'll stick around for a few minutes to answer those. And otherwise, I hope that you all learned something. But if you need any additional help outside of the webinar, always feel free to give me a call or send me an email. All right, it looks like we don't have any questions right now. So I'll go ahead and let y'all go. But thank you again for attending, and we hope you'll come to our next webinar. Have a good day.